Alright, in this video we're going to continue talking about the unit circle and talk about some of these special terminal points that we should know and be familiar with on the unit circle. Now, if you don't look at the first video that I did about the unit circle, where I just talked about the definition of the unit circle and what we mean by a terminal point, I would advise you to watch that video before you watch this one, because if you don't know what the unit circle is or what a terminal point is, then some of this stuff might not make sense, right? But just real quick, the unit circle, if you recall from watching that video, is a circle with radius 1 with the center at the origin. Right? So that's what we call the unit circle. And I drew up here 4 different examples of the unit circle because we're going to look at 4 different t values and their terminal points. Right? We're going to look at 4 special terminal points in this video here. And then I'll do another video where we look at some of the other special terminal points that you need to know. Alright, so some special terminal points. Well, first off, for the unit circle, right, it's a circle with radius 1. Okay? So my first special terminal point is going to be, well, what if I travel 1 lap all the way around the circle? Remember, when we're doing t values and terminal points, we always start on the positive x-axis, right, at the point 1, 0. That's our starting point. And then if, for positive t values, I go counterclockwise, I start moving upward, and I go a distance of t to get to the terminal point. For negative t values, I go the other direction, I start going downwards and move this direction, an absolute value of t units to get to my terminal point. All right, but what if I travel 1 full lap around the circle? All right, what if I go all the way around and I end up with my terminal point right back where I started? Well, that terminal point is 1, 0. Right? Remember, the unit circle has a radius of 1. The center is at the origin. Well, if the radius is 1, then from the origin out to this point has a distance of 1. But if that's just straight along the x-axis, it's at x equals 1. All right, so the terminal point is x equals 1, or is at 1, 0. The question is, well, how far did we travel around the unit circle? What was the t value that took us 1 full lap around, 1 full circumference of the circle to end up at the point 1, 0? Well, I kind of just said it. It's the circumference of the circle. And if you recall from geometry, the formula for the circumference of the circle is c equals 2 pi r. Right, that's the formula for finding the circumference of a circle. Right, but for the unit circle, the radius is 1. Right, so the circumference equals 2 pi times 1, which means 2 pi. Right, so the circumference of my unit circle is 2 pi, which means if I travel all the way around the circumference, I travel a distance of 2 pi units. Right, remember, the circumference is the distance around the outside of the circle. So 1 full lap around the outside of the circle is a distance of 2 pi. Right, so if my t value is equal to 2 pi, I have a terminal point of 1, 0. Right, 2 pi, 1 full circumference, all the way 1 trip around the circle, we end up with a terminal point at 1, 0. All right, so the first really important terminal point to know, when t is equal to 2 pi, our terminal point is 1, 0. 2 pi means 1 full lap around that circumference of the circle. All right, so it's just one of those ones you need to know, that all the way around the unit circle is a distance of 2 pi. All right, so that's that one. I'm going to erase this stuff here to put the next one up on the right here. All right, so if 1 full lap around the circle is a distance, a t value of 2 pi, well, what would be halfway around the circle? Right, once again, I start on the positive x-axis, but what if this time I only go halfway around the circle? Well, that takes me to the negative x-axis, so the terminal point is going to be -1, 0. Right here, I'm still 1 unit away from the origin, right, because of the radius of the circle is 1. But if I go that 1 unit along the negative x-axis, I end up at the point -1, 0. Right, so the terminal point there is -1, 0. What's the t value? Right, remember, the t value is the distance that we are traveling along the circumference. Well, if 1 full trip around the circle all the way around is a t value of 2 pi, well, halfway around the circle would be half of that distance, and half of 2 pi is 1 pi, or just pi. All right, so halfway around the unit circle has a t value of pi, which gives us the terminal point -1, 0. Right, so again, another important one to know. You need to know that if you go halfway around this unit circle, you've traveled a distance of pi units, and the terminal point is -1, 0. All right, so those are our first 2 special terminal points. All right, the other 2 terminal points we're going to look at is the ones on the y-axis, right? The positive y-axis and also the negative y-axis. Right, so for the positive y-axis, I know that that terminal point is going to be 1, 0. No. That's not true, right? The terminal point there is going to be 0, 1. All right, x is 0, y is 1. Again, I'm on the positive y-axis on the unit circle, which has a radius of 1. If I travel that radius of 1 along the positive y-axis, I end up at y equals 1, x equals 0. Right, so the terminal point here has a value of 0, 1. Right, those are the coordinates of that terminal point. The question is, what is the t value that's going to take us to that terminal point? Well, the t value to get up to the y-axis, the positive y-axis, is half of the circle. Right? There's a couple ways to think about it. You can think about it as, well, this is 1/4 of the full circle. So it's going to be 1/4 or 1/4 of 2 pi. Maybe an easier way to think about it is, halfway around the circle is a distance of t equals pi. Right? T equals pi, that's a distance of halfway around the circle. The positive y-axis is half of that, right? It's half of that half circle. So my t value here would be, there's a couple ways to think about it. It's 1/2 of pi, right? And think about that. Understand why that's true, right? From here, from the positive x-axis, halfway around the circle to the negative x-axis is a distance of t equals pi along that circumference. If I go from the positive x-axis up to the positive y-axis, that's only half of the distance that we had up here, right? So if this distance up here is pi, half of that is going to be 1/2 pi. Now, normally we don't write that as 1/2 pi, but we simplify it a little bit. Not really simplify it, but we write that as pi over 2. Right? Just because when you think about this as 1/2 times pi over 1, I get 1 times pi over 2 times 1, that's pi over 2. Right? So when you see pi over 2, think of that as 1/2 pi. Right? If you know that pi is halfway around the circle, well then half of pi is half of that distance. It's only 1/4 of the way around the circle. Right? So when my t value is pi over 2, that's 1/4 of the full circle. Right? And again, if you do 2 pi divided by 4, you get pi over 2. Right? So you can check that out if you want to see that that's true. So there's a couple different ways you can arrive at that. But if I only go 1/4 of the way around the circle, I've traveled a distance of pi over 2, and I end up at the terminal point 0, 1. Right? The terminal points themselves, when you're looking at the unit circle, should be pretty easy to figure out what the coordinates are, especially the ones on the ones on the positive or on the x and y axis should be easy to figure out. It's either a 1, 0, a 0, 1, or a -1, 0, or a 0, -1. It's all zeros and ones, and sometimes the ones are negative, depending on where you are. All right, so for the last terminal point we'll talk about here, on the negative y-axis, well, I know on the negative y-axis that my coordinates are going to be 0, -1. Right? X is 0 because I'm on the y-axis. I travel down 1 unit because the radius of that unit circle is 1. When I travel 1 unit down on the y-axis, I end up at y equals -1. Right? So the terminal point there is 0, -1. The question now is, well, how far am I traveling around the circumference of the circle to get to that point? All right, what is my t value that takes me to the terminal point 0, -1? And again, there's a couple ways you can think about it. You can think about it, well, going all the way down to here, that's 3/4 of the circle. Right? So if I do 2 pi times 3/4, that's going to give me that distance there. Or you can think of it as, well, it's pi, right? It's halfway around the circle, which is a distance of pi, plus another 1/4 of the way around the circle, which is a distance of pi over 2. So it's pi plus pi over 2. Right? And that's the way I'm going to think about it. All right, so if I go halfway around the circle, that's a t value of pi, right? That's a distance of pi units. And then 1/4 of the way around the circle, like we saw up here, is another half pi, or pi over 2 units. Right, so if I add pi plus pi over 2, that's going to give me the t value that takes me all the way down to that negative y-axis. Right, so what is pi plus pi over 2? Well, if I want to add fractions, I need to change this to a common denominator. Think of that as pi over 1. I have to multiply the top and bottom by 2. So I get 2 pi over 2 plus 1 pi over 2, which is going to give me 3 pi over 2, or 3/2 pi. All right, so this t value is going to be 3 pi over 2, or think of it as 3/2 pi, right? Or 1.5 times pi, right? It's 1 pi and then another half of a pi. It's 1.5 pi, but we don't give that as a mixed number. We give it as 3/2 pi, or 3 pi over 2. All right. Or again, another way you can come to that number is take 2 pi, the full distance around the circle, multiply that by 3/4, right? Because this distance here is 3/4 of the full circle. We're going through 3 of the 4 quadrants, right? So it's 3/4 of the total way around. If I do 2 pi times 3/4, I'm going to get 3 pi over 2, same result. Okay, so those are the first 4 special terminal points that you really need to know on the unit circle, right? And they're all based on the circumference of the unit circle is 2 pi, right? If you can remember that and you forget these other ones, you can piece them together, right? All the way around the circle, well, that's 2 pi. So halfway around the circle, well, that's just 1 pi. Half of that is pi over 2. Half way around plus another quarter, that's 3 pi over 2. And you can kind of put them together that way. All right, so those are our first 4, like I said, special terminal points. What I'm going to do now is pause this recording and erase these ones that are up here. And then I'm going to put up a couple examples where we do similar types of terminal points. And we try to figure out, given the t-value, what is the terminal point. All right, so I put up here 3 examples where we're given a t-value and we're asked to find the terminal point for that t-value on the unit circle. So the first one is t equals 3 pi. All right, so what I'm going to do here is draw a little unit circle, which is just the x and y axis and then the circle with the center on the origin. All right, so there's my unit circle, and now I want to travel a distance of 3 pi around the unit circle and see where I end up. What's my terminal point? Remember, the terminal point is the x and y coordinates of the point that you end up at when you travel a distance of t equals 3 pi around the unit circle. All right, and remember, when you're traveling around the unit circle, you always start on the positive x-axis. So I'm starting over here and I have to travel a distance of 3 pi. Well, think about it like this. If I go all the way around the circle, that's 2 pi, right? So that's, so that's 2 pi, and then another 1 pi takes me halfway around the circle again, which leaves me here, and on the negative x-axis, my terminal point is -1, 0. That's going to be my terminal point for 3 pi, right? So I'm literally counting, or you can count it like this. Like if you know that pi or 1 pi is halfway around the circle, you can just count pi's. So halfway around, that's 1 pi. Another halfway around is 2 pi. Halfway around again is 3 pi. I end up here at the terminal point -1, 0. Right? So t equals 3 pi, shares the same terminal point with t equals pi that we saw up over here before I erased those examples that were up before. Right? So different t values can share the same terminal point because, we have a circle here. So if you go more than one circumference around the circle, more than a distance of 2 pi, you're going to end up at some other point that you've already gone past. And so different t values are going to give you the same terminal points, as we see here. All right, the next one, t equals -pi. All right, so once again, let me draw a quick little unit circle. So we have to start at the positive x-axis. Now, remember, if my t value is negative, I travel in the opposite direction. Positive t values, I start here and I travel counterclockwise. I start moving upward. For a negative t value, I travel clockwise. I start moving downward. And I go a distance of not pi, well, not negative pi, but pi itself. Right? So the positive and the negative just tells me which direction to go. But then when I'm actually traveling that distance, I ignore the negative and I just move pi units. Right? And once again, pi is halfway around the unit circle. Right? So I'm just going halfway around the unit circle, but in the opposite direction as what I did before. And once again, I end up at the terminal point, -1, 0. Right? So 3 different t values that we've seen already have the same terminal point. T equals pi, t equals -pi, t equals 3 pi. There are actually an infinite number of t values that will give you the same terminal point. Right? Because I can keep going around the circle. Every time I go around the circle one more time, I keep ending up at that same terminal point. Right? So there are an infinite number of t values that will give you the same terminal point for every terminal point on the unit circle. All right? The last one here, t equals -pi over 2. All right, so let me draw another quick unit circle. Remember, pi over 2 was up to the positive y-axis, right? That was 1/4 of the way around the circle, or half of pi, half of halfway around the circle. Right? Half of half is a quarter. Right, but -pi over 2, I go in the opposite direction. So I start on the positive x-axis, but I'm traveling downwards through the 4th quadrant, and that takes me to the negative y-axis, where the terminal point is going to be 0, -1. Right, so -pi over 2 shares the same terminal point as 3 pi over 2 that we saw a few minutes ago. All right, so Again, the positives and negatives tells you which direction to go, and then like the pi over 2, the pi, the 3 pi over 2, 2 pi, those are like your guideposts for each quarter of the way around the circle. Each time you get to one of the axes, those are the numbers you're going to see.